It's really nice to be here and to get to share some thoughts on transitioning to other kinds of applied math other than what Elijah was talking about. So like many people, I had a real love for mathematics from when I was in high school. And, I think when people say that they love math, most of us mean that we love the process of doing math. So sort of the way of thinking and the method of questioning. And we love sitting with that pile of notes in our office, like Elijah said. And so at some point, with the encouragement of people like Brian and people like my undergraduate mentor at Dartmouth, people started to say, it seems like you really love this. You love spending time on it. You should think about going to get a math PhD. And actually, you're learning enough that that's something that you should see as an option for you. And I think that in my experience, that was how a lot of students got nudged to go further in math, is because someone told them that they could and that they liked doing it. And so then they thought, well, maybe that's what I should do. And it turns out those are kind of different questions, because when you're thinking about what you should do, a really important question to think about is, where would that lead me? Where would I be going later? And would I be happy with the path that would put me on? And so in my case, I was really lucky to be exposed to a couple of different internship opportunities. So I worked at the National Security Agency when I was in college, and I had the opportunity to work with a lot of great mentors there. I ended up working with an economist when I was a senior in college and sort of got some experience with what that was. And so even though I was planning to go get a math PhD, I felt like the process of those kind of late accumulated experiences in college gave me some insight into what different careers were like that use mathematics, and actually gave me a sense that even though I love doing math, actually getting a math PhD was kind of going to put me on a track that was not exactly the right track. And so what kinds of things did I learn that made me think about careers and what PhD was right for me differently? So when I was trying to put together these slides, I thought about different dimensions on which careers that use mathematics differ that I think often are underemphasized to students when they're thinking about which graduate degree or what career path is right for them. So one is just the day-to-day emphasis. So is what you like teaching, is what you like doing research, or is what you like what I would call like practical problem solving? And so for me, I always think of practical problem solving as either, you're working in a firm like Amazon that needs, to do something better and you're trying to help them solve their problem, or you're working in government and we need, better COVID numbers and it's your job to try to produce those and get them made publicly available. But it's a much more focused thing than what I would think of as research, which is, long term, and whenever you come up with an answer, that's fine. And so it turns out different people find those rewarding in very different ways. And so it's not that there's one that's kind of right for everybody. You kind of need to reflect on, what do I actually enjoy doing and what do I like for a day-to-day schedule. A lot of people do decide they like research, so I was one of those. And then within research, I feel like one really important dimension is how tied is the work you're doing to problems that you're really driven to want to solve. And so in my case, I was really interested in trying to solve social problems, making society better. And, as mathematicians, a lot of us write, grant proposals where we kind of talk about the applications of our work and why it's important and how it can benefit society and things like that. But it's one of the relatively further away, relationships that you would draw. On the other end is working in policy, like Elijah's doing, where it's extremely obvious kind of on a day-to-day basis that what you're doing is immediately policy relevant. And then there's, on that continuum, sort of some research that's not informing short-term policy, but is sort of more directly motivated by and trying to speak to policy questions. And for me, that kind of felt like the sweet spot, because I don't really find it to be a good fit for me personally to have like the day-to-day rush of extremely focused problem-solving work. But I like my work being tied in a very direct sense to policy questions. And so math felt a little far away, but academic research on social problems felt like sort of a good fit on that dimension. A third dimension that I thought about is whether you're given problems versus you're choosing your own problems. And so a lot of people think that everybody should have the same preferences over that. Isn't it always better to choose what you do? And that's the opposite of how I would frame it. So a lot of students go to get their PhD, and the most stressful part of their PhD is needing to choose questions or find questions, as if there's a shortage of questions that the world needs answered. So one example just close to my own area of economics is, economics PhD students spend a lot of time beating their heads against the wall of what are interesting research questions about how to design health insurance exchanges, so places for people to go buy affordable health insurance policies. As opposed to, you could just go work at the Massachusetts Health Insurance Exchange, which is trying to provide people with health insurance policies, and go help them improve how they do that. And so, some people really like this more academic nature of thinking about which questions are interesting, but I think a lot of people are very much happier kind of going to a space where you're working on the same issue, but you're working in an organizational context or in a area where the questions that need to be solved, everyone knows what they are. And it's very clear that if you want to have high social value, you can work on those questions. And so that's just something that, again, I think students often assume that they would always prefer to choose their own problems, but I think actually a lot of people don't find that to be sort of the right fit with their motivation and interests. And then the last one that I would emphasize is whether you want to work independently or part of a team. And so there's been a lot of movement in recent years that academia and academic research has become more team-based in the sense that people co-author more. But in many ways, it's still very lonely in the sense that you're sort of an entrepreneur. You collect co-authors for different projects or collaborators for different projects in your lab, but you have a vision for your career and what you're doing. And I think a lot of people at the end of the day just don't find that to be a very rewarding fit with what they're interested in. And they would much rather work in a team setting where you're sort of all working together collaboratively towards a very organic kind of goal that you all have. And so for me, I actually really like sort of having an independent agenda, but I think I've seen a lot of students over the years that think they wanted that actually over time realize that they actually thrive much more in a team-based environment and enjoy that part of the problem. So those were some of the kinds of problems that I thought about of sort of how do I think about what career I would be happiest doing? And based on my own reflection and kind of answers to those questions, I ended up changing plans and sort of dropping out before I started. But I had applied to a math PhD and gotten accepted and was planning to go. And then I decided not to go. And I applied to PhD programs instead in economics. And I thought that within economics, I wasn't really sure at the time I started whether I wanted more of a practical problem-solving policy career or an academic career. But over the course of grad school, it became pretty clear that academic careers and economics was really the good fit for me. So I want to give you one example of the kind of question that motivates my work, and then just tell you a few examples of the kinds of things that I've worked on. So the reason I love my job and my research is that I get to ask questions like this. So why don't we have a cure for cancer? And so that's not a question that is a mathematics question or an economics question or a health question or a medical question or a science question. Lots of different people from different fields can have opinions on what the answer to that question is. And so I like that in the sense that I like talking to people with a variety of skill sets about what they think is going on that explains, the answers to important questions, and then trying to process that and reflect on how I think I could best contribute to trying to go about answering them. And so if you ask scientists and doctors, the main answer that you get is that the science of curing cancer is just really hard. And so that's like a really hard challenge. And so we haven't done that because it's difficult. And so it's kind of a pessimistic view because it sort of suggests that more money is not really going to fix the problem. More people are not obviously going to be able to solve the problem. And so we're just kind of left that maybe we're not going to cure cancer. For economists, we often get tagged as being very dismal and not very optimistic. But here we actually have sort of the optimism to bring to this kind of challenge. So for economists, we often think that the state of what's hard and not hard in science is largely determined by how much effort and money and labor, people has been expended in trying to answer it. And so some questions are hard because they're innately hard, but some questions are hard because we haven't spent a lot of time and money trying to solve them. And so it's possible that if we change public policies and we invest money differently, we kind of encourage students to go work on areas that they haven't been working on, that problems that today seem hard will seem easier later. And so, the whole idea of like, how do you get a COVID vaccine at some point seemed, very hard. And then people figured out how to do it. And that was partly because we spent a lot of money and put a lot of people on the problem. And so that perspective is very much uniquely a social science perspective, because the idea is how do we design policies to get solutions to problems that we want to have? And unless you have some hope that, designing policies differently is going to change behavior and going to make some scientific problems easier to solve that were used to be hard to solve, there's no reason you would be inspired to go into this field. But that's a view that really resonates with me. So I kind of feel like it's not true in every context. Sometimes there really are hard problems that are just not going to be solvable. But I think in a lot of cases, if we sort of redesign incentives and redesign public policies, you do have the opportunity to make progress on things that we have always thought of as very difficult. And so I'll just briefly talk about 3 examples of some of the work that I've done in this area. So this was a paper with a couple of co-authors of mine. One is a lawyer and one is more of an economic theorist and sort of more mathematical economist, where we tried to think about what explains why we get certain kinds of cancer drugs developed and not others. And so the basic idea is very simple, which is if you read the Wall Street Journal, you sort of get the sense that most cancer drugs are developed to treat patients at the very end of their life. So they sort of extend your life expectancy from 6 months to 8 months when you have metastatic cancer. And it's pretty rare that you hear about cancer drugs that are coming out to treat early stage breast cancer and sort of prevent women from dying of breast cancer. And so we were interested in, is that because it's easier to develop drugs to treat these late stage cancers? Or is it because sort of the structure and incentives that society has makes it more profitable for people to develop those drugs for late stage cancer and less profitable to develop drugs for early stage cancer? And so we started with a very simple idea, which is that for drugs, a lot of investment is motivated by the prospect of getting a patent. And it turns out that you need to get a patent before you start clinical trials. And so if your clinical trial lasts longer, more of your 20-year patent term is spent in clinical trials and less of it is spent actually selling a product that you make money on. Whereas if you do a clinical trial that's completed very quickly, you have more of your 20-year patent term that you can sell your drug at a profitable price and less of it that you're just in clinical trials trying to learn about whether it works. And so it turns out clinical trials for late stage cancers tend to be quite quick because patients die relatively quickly. You can do a simple statistical power calculation to show that. And so the trial that you need to show that patients live longer on the treatment can be quite short. And so as opposed to if you're trying to show that patients with early stage breast cancer live longer because of your treatment or because your drug actually prevents cancer, those trials often actually need to be longer than 20 years. And so you get a patent before you start the trial, and actually by the time your clinical trial is finished, you don't have any patent term left. And so you're immediately facing competition from other people and you sort of never have any time to charge a higher price and recoup the value of your investment. And so we tried to look at the data in a bunch of different ways to try to disentangle, is that story relevant? So is it that we see more of these late stage cancer drugs rather than early stage cancer drugs because of the incentives provided by the patent system and sort of other things? Or is it actually just because of, the things you'd hear from doctors about the science is just harder for those drugs? And so that's a paper that I really enjoyed working on, and it feels a little bit like detective work, but it's essentially, just thinking through how do you find the right data? How do you think about constructing something which is like a randomized experiment, like we'd use to evaluate a drug, but in a context where we don't have a randomized experiment. And so I find that kind of work really exciting and rewarding. The second example I wanted to give is there's a lot of controversy some years ago about whether we should have patents on human genes. A lot of that was a very philosophical level controversy of, should you be allowed to own things that are in my body? But actually, when the Supreme Court ended up making this decision that, could be interpreted as saying genes are no longer patentable, so you can't have patents on DNA for humans, what they argued was not based on the philosophical argument, but it was rather based on a really practical argument of, they basically conjectured we would get fewer medical technologies developed if genes were patented than if genes were not patented. And so that's a testable claim, but the Supreme Court didn't have any data on that. So they were just asserting based on their best guess of where they thought the costs and benefits were falling. And so both in my dissertation work and then in a follow-up paper that I published about 10 years after that, I did a lot of work to try to think about how can we actually systematically measure whether gene patents are good or bad for society. And so, you could think, well, aren't they obviously bad because they're going to limit access to things? But if the prospect of getting a gene patent actually encourages people to do more investment, then there's potentially a trade-off where patents might have some initial encouragement for inventions, and then they could potentially get in the way of when people are actually trying to invent things. And so these para papers was basically trying to design different kinds of empirical strategies, again, kind of mimicking randomized experiments in a case where, because of the setup, we don't actually have a randomized experiment, to try to learn about the answer to that question. Okay. And then the third example is that there's been a lot of concern recently. There's been a lot of concern for a long time. I would say that it's become more in focus in maybe the last 10 to 20 years about rising levels of inequality in developed countries like the US. And so, if you look at sort of a list of who the richest people in society are, a lot of them are people that run very innovative firms, and a lot of them are profiting from the policies that we put in place to try to encourage innovation, like the patent system. And so this was one paper that we did that was trying to say, basically, who is benefiting from patents? So when a firm like Amazon gets a patent, do they pass some of those profits back to workers in the form of wages, or are those profits going to shareholders? And how do we think about the policies that we use, because we think that society is going to be better off, not in terms of their overall effect on growth and society, but also on the distribution of who gets money, who sort of is better off. And so this particular paper was kind of a long effort where we were linking all of the administrative data from the patent office with individual tax records, so that we could look at your wages and which firm you worked at and when your firm got a patent and things like that. And so, it was just sort of a labor of love to put together the data to do that. But what we found is on a variety of dimensions, it looks like patents do increase investment, but they do so at the expense of increasing inequality, both within firms and across firms. And so I think those kinds of numbers are important for thinking about, rather than just saying, this policy makes society better off or not. We also need to think about who's benefiting and how we take that into account in terms of our policy decisions. So Brian has been a huge impact on my life at many different points, and is somebody that I've really appreciated. And so I guess what I would say, when you're thinking about career paths, probably the best thing you can do is listen to your mentors, and also seek out thoughtful mentors, because at the end of the day, they're going to be the people that know you best and can kind of talk you through things. Reading advice from other people like me, maybe will give you some questions to ask your mentors, but by far that was the most important thing for me. So let me wrap up there so that we have some time for questions if people have them.
Yeah, we'd be happy to ask some questions of Heidi. You can put them in the chat. I noticed the last paper was 60 pages long. And so that tells me there's a lot that goes on in making the case. So the question is, how much of it is quantitative and how much of it is, let's call it, philosophical discourse? In other words, from the hard numbers to the soul searching, and economics is somewhere in between. How does that play out in a paper like that?
Yeah, so I would say one reason that my papers are long is I spend a lot of time constructing new data and thinking about new ways of measuring things. And so I think that's true in a lot of data science sort of related fields. Is one reason why COVID tracking was something that had a completely parallel effort to the government at some point, was because there was just literally measuring the data and getting the right numbers was just a real challenge. And so now that's been switched back over, is being switched back over to the CDC. But where does your data come from? Are you measuring things in a meaningful way, and trying to convince people, especially when you're constructing new data, that it's measuring something meaningfully, so you can kind of validate it? That is probably, for me at least, 40 of the 80 pages, whatever. And so that's not always the case. Sometimes you're reusing data that other people have used, and then that section can be a page or a page and a half. But I really like constructing new data and trying to find new ways of measuring things. And so in my papers, that takes up a lot of the space. The second piece, which takes up the most space, is usually this process that I kind of referred to as trying to create something like a randomized experiment when you don't have one. So, when you want to know whether a drug works, you give it to the treatment group and not the control group, and you just measure stuff. And that's about a page. And so it turns out when you don't get to do a randomized experiment, that's when it's about 30 pages to try to, propose something that you think is like that. And then again, kind of test and validate the assumptions that you need for that to be true. So one example, to be concrete, is for the gene patent case. So you want something that effectively randomized some human genes to be patented and other human genes not to be patented. And so I had an idea from reading some interviews that people had done with patent examiners at the patent office, that some patent examiners are kind of strict and others are lenient. So, on average, they kind of grant a lot of patents, and other ones, they're kind of grumpy and they don't grant a lot of patents. And it turns out that at least in some technological areas at the patent office, which examiner reviews your application is basically random, because it's sort of a first in, first out rule. So, whoever last completed their patent application review gets the next one. And so I had an idea that even though that's not purposely a randomized experiment, that maybe we could use the fact that examiners are very different from each other and this kind of first in, first out procedure to reconstruct something that would mimic a randomized experiment. And so nobody had done that before. So you can kind of say, well, this is like a randomized experiment, but then no one would believe you because you kind of need to show them that actually it looks random. And so you sort of need to think about what are the things I could tell you about. You might think that these patents are very different, but in fact, on average, patent examiners get assigned very similar patent applications. That would be kind of one assumption that you need to think that this is a valid randomized experiment. Because in a real randomized experiment, the patients that are in the treatment and control group look similar based on like their comorbidities when they come into the trial. But with patents, it's not clear what the comorbidities of the patents are. So you kind of need to construct, what are value measures of, patent applications at the time they're submitted? And then can I construct tests for showing that, lenient and strict patent examiners get similar valued patent applications based on the information we have at the time that they were submitted. And so anyway, it's sort of all of that is doable. It's just complicated and takes 30 pages. And then for me, at least, the empirical tests are usually actually about 2 or 3 pages. Because if you've constructed something that you think is a compelling randomized experiment and you have data that is measuring something meaningful, then you can actually do a pretty simple tabulation to show people what's going on. And so other papers have, 60 pages of the actual empirical work, but mine tend to be more focused on the measurement and the experiment design.
So Amelia asks, do firms invest in long-term research?
Want the answers to questions? Yeah, of course. So we found, yes, we found evidence that essentially private firms seem to invest more in short-term projects, so projects that can be completed relatively quickly relative to what we as society would want. And so, one marker for what we as society would want is when the public sector funds research projects, it tends to fund longer-term projects. And so we kind of talk through what are different reasons why that could be true. One concern that people have is just private firms may be more responsive to short-term pressures from like shareholders that we need profits in the short term. We don't want to do these really long-term projects. Some factors actually might bias both the public sector and private firms towards short-term projects. So one way of thinking about that is, if I come up with an idea today and I do a clinical trial to show in 7 years whether it's good or not good relative to a placebo, by the time I finish my trial, it might not be the best available technology because somebody else might have developed something better in the interim. So that's not a bias towards short-term research. That's just the fact that, competition is a thing that happens in society. And so we try to isolate factors like that of just why might both the private sector and the public sector face an incentive to invest in shorter term projects. And so we're setting those aside and saying it looks like private firms do underinvest in these long-term projects relative to what the public sector or society might want. And so that's the answer. So then we talk about how could you try to fix that? How could you try to encourage firms to develop more of these longer term projects?
Okay. Any other questions? There used to be a thing called Bell Labs. It was a massive organization, and it doesn't exist any longer. Now, a lot of this has to do with the breaking up of the phone company, but at the same time, there was this notion that, corporations had to go for the bottom line quicker, economic constraints. And I'm looking at Rich Laverty and Jeff Alden, who both work in industry. And so there's no indictment here, but it's just that longer term research may not be as commonly done in the private sector as it was. Is that a fair statement?
Yeah, so it's interesting. I mostly work on biopharmaceuticals, like health technologies. And so, there over time, what you've seen is a shift towards more of the basic research as a share of basic research is being done in universities or at small firms, and the larger firms are more specialized in kind of buying technologies from universities or small firms and developing them through the clinical trial process and the drug development process. And so, one way of saying that is just who is doing the basic research is changing. And you could think that's good or bad, because maybe universities are actually sort of the right place for basic research to be done, because there's just, maybe faculty have more of an incentive to do long-term projects than we should be expecting private firms to have. But I remember once when I presented that paper, one of the faculty members that was in attendance said, there's also a tenure clock distortion, which, he meant a little tongue in cheek, but it's just to say, it's not that academics don't have any time pressure, for what their work is producing either. And so I often think of this as it's just, we kind of know what kinds of research is long-term research. Climate change research is a great example, right? It's not just that it's going to take a long time to develop some of these things, but actually when they're first developed, they're not going to be profitable because they're going to be very high cost and we're going to need to charge high prices. So it's going to be hard to get people to buy them. And so we sort of know where the problems are. And I think it's just important to think about designing public policy to subsidize those areas where we think we know that there's going to be underinvestment. And so, another good example is an Alzheimer's drug, where I think a lot of people think that treating Alzheimer's is probably most effectively done at age 30, but most people develop Alzheimer's when they're 80. And so to expect a private firm to do a clinical trial of let's enroll a lot of 30-year-olds and wait till we can observe whether those people develop Alzheimer's when they're 80, that seems like something we may not want to wait around and expect private firms to do on their own. So maybe we should just publicly fund a trial like that. And so I guess it's just sort of a good reminder that we don't need to act as if we have no idea, where these problems could have. It's sometimes we know, sometimes we don't know, but I think sometimes we do, and we can actually intervene and do things.
So one last question. Jeff Alden, who's going to be speaking later, is at GM, and he goes, at GM, there's a mix. We have a research arm that can do some long-term research. Yeah. Of course, GM has gotten a lot of news coverage in its Go Electric by 2035. And in some sense, 15 years is a long time. In another sense, it's tomorrow, depending on what it is you're doing. But so you're suggesting, Heidi, that many firms are doing long-term research. And just because Bell Labs disappeared doesn't mean the whole shebang is over, right?
I think that's right. And, it's a little bit hard to know because we don't always have a window on what's going on in different firms, and different industries are very different. Yes. But definitely you can get some anecdotes like that that suggest that this isn't just because Bell Labs has gone away doesn't mean that, no one is doing that.
Yeah. Well, let's thank both Heidi and Elijah very much for their talk. Okay. They'll be around, and you also know how you can get in touch with them if you want to learn more. And of course, this video will be up with all the others recorded from this probably in 3 weeks or so, and we'll make that information known to you. We're going to take a break. Our next talk is the keynote speaker, Matt Balkins, who I see smiling, at least his icon is smiling. And that'll be at 12:45. So again, thank you, Heidi and Elijah. Oh, here's Matt. He's smiling as well. Okay. Well, thank you very much all. And we'll see you in a little while at the main room. Bye now. Thank you, Heidi. And thank you, Elijah.